Hello everyone, we're group 15, and today I'm going to talk about variables and data types. So every games you played, every programs you've used, they all have to remember things somehow. And that's where variables and data types come in. A variable is simply a name that have a value or stores a value in memory. It's kind of like a box labeled with a name. For example, you can create a variable name is equal to Alice. So the name is the variable and the Alice and is the value. So when you print the variable name to the console, it will print Alice. So a naming convention, you must start the variable with a letter or an underscore. You can only contain alpha, numeric characters, and underscores. Variables are also case sensitive and cannot be any of the Python keywords. There are two way of naming that are prevalent. That is snake case and camel case in the example in the corner. You can assign multiple variables at the same time to save space. And you can also reassign a variable. So you can change the variable's value after you've declared it. About the data types. There are a lot of data types in Python, but there are 5 basic data types. The first one is integer. So integer is kind of like a round number, the round number data type. And there's also float. It's like the round number data type, but it has decimal and the number after the decimal. So it's more precise. There's also string. It's basically just text. There's Boolean, which is true or false, the data type. And there's also none. It's the none type, which is basically they contain nothing. Moving on to objects and type conversion. An object is an instance of a data structure that holds both data and methods. For example, you assign the variable x to 5, the value 5. And when you print the ID of x, it gives you the identity of x. So kind of like the code of x. When you print the type of x, you will get the data type of x that we mentioned earlier. So in this case, x equal 5 is an integer. And when you print the x itself, it gives you the value of x, which is 5. Different data types cannot be added together or concatenated together. So we need to convert them. We can do that using the functions int, float, boolean, and string in the example below. Hello guys, I am Dat, and I'm going to show you guys some common mistakes with variables and data types. So we're going to have this variable here. We're going to try to print it to the console. And it raises an error, a syntax error, because you cannot name a variable like this. And we can also do this. You also can't print it because there's like a special character at the start. So here's the correct way. You can use this. This is called a snake case. You could also use this. It's called a camel case. And when you print it to the console, it will work. It will print the variable, print the value of the variable. There we go. Okay, moving on to the concatenation of different types. We're gonna create a greeting and print it to the console. gonna print the greeting, and it has an error. This is because you cannot concatenate a string with an integer. And this is how we fix this. Now we convert the age integer into a string, and then we run it again. And there we go, that's the result. So that's two of the main problems that a lot of people often struggle with. That's it. That's invalid variable and concatenate different types incorrectly. That's all.
Okay, so let's come to the exercise of the first part. We will have the first exercise here to calculate the area of the circle based on the user's input. So here we will define the variable with radius to take the input of the users. So if you write it like this, it will return the radius as a string, as a type string, and you cannot perform calculations with the radius. So I will have to convert it into float to perform the calculations on it. We will take p equal to 3.14, and the area of the circle will be equal to squared radius and multiply by p. Now let's print out the result. Okay, we will have the desired result here. So the first exercise is pretty simple. Let's move on to the second exercise. Okay, so we will come to the second exercise about type conversions and string concatenation. Now we will take the name of the persons from input and their age also from input. So in this case, I will also have to convert the age to the integers. So that's we can perform calculations on it. For the next step, we will calculate their year of birth using that years of birth would be equal to 2025 minus by age. And now we will print out the result using the string additions. We will have name plus is born if and plus the year of birth. Okay, so I will type in the name of the person and their age. And so in this case, we will have to, when we run like this, we will return an error because the year of birth is an integer. So we also have to convert it into a string, and I will reprint it. Okay, so this is the desired result with our exercise.
So when we talk about list and other sequences, we talk about the definition of it. In Python, a sequence is a general category of data types that store an ordered collection of elements. These elements can be accessed by their index, and the order in which they are stored is preserved. Common sequence types in Python include string is just simply a sequence of characters. A list is like your editable playlist in Spotify. You can add, remove, or rearrange items. A tuple is the locked version. Once you create it, you cannot change it. And a range, finally, is like counting automatically from one to another number. So when we create a list, we just wrap it in square brackets. For example, we have apple, banana, and cherry, and we just wrap it in square brackets with the dash in the middle. And there we have a list, and then Python will automatically remember the order of these elements that we have created. In accessing elements, if you want to get a specific element, you use its index. You can think of this as its seed number, but we have to remember that Python starts counting from zero. So the zero index is the first item, one is the second, and so on. So when here, for example, we have this sublist is biology, it is actually 0, and chemistry is number 2. In modifying, adding, and removing items, lists are very flexible. You can change, add, or remove elements easily. You can think of append as adding a new item at the end, insert as placing something in a specific position, pop as removing the last element, and remove as deleting a particular value from the list. The extend method adds the specified list elements or any iterable to the end of the current list. Moving on to slicing and negative indexes. Sometimes you only need part of a list. That is where slicing comes in. This gives you items from the index 0 to 2, but not including index 2. You can also use negative indexes to count from the end. For example, fruit -1 gives you the last items in the list. This is useful when you don't know how long the list is, but you actually need the final element. Finally, iterating with for loops. You can loop through a list using a simple for loop like this. It actually goes through each element one by one, performing the same action each time. It's like playing every song from your playlist from start to finish.
So I will introduce you to some other sequences. The first one is tuple. Basically, by the definition, a tuple is a collection which is ordered and unchangeable. Unlike list, which use parentheses, tuples use square brackets. So for example, here I have a variable named my tuple, which store a tuple with different types of data types. The first one is integer 1, the second one is string banana, and the third one is boolean true. And I can access each component in the tuple by using index. I access the component with the index 1, which is the second component, banana. And if I try to change each component in the tuple, for example, I change the index 1 component in my tuple, banana, to a new value apple, it will cause type error because by the definition, tuple cannot be changed. And the second sequence is a string. By definition, a string is a sequence of characters. You can access each character by index, but you can't modify individual characters. So I have a variable named s with with a string value hello. If I try to access each component, which is each character inside a string, for example, I access the character with index 1, I will print out e. And like tuple, I cannot change the character inside a string, so it will cause the type error. The third sequence is range. Range represents a sequence of character and often used in loops. It doesn't store all numbers in memory, but it generates them on demand. So on the right-hand side of me is the correct complete syntax of range. The first number is start, the second is stopping number, and the third one is stepping number. And oftentimes you can also write two number which represents for start and stop. For example, in my code here, I have a variable or with assign with the range from 1 to 5. It will loop the numbers consecutively from 1 to the number before 5, which is 4. And if I try to print or I will not have the full list of numbers inside a range because range is just an object, it's not a list. So to access each number in the range, I will convert it into list, or I can use the for loop. Here I have a table of comparison between 4 sequences that we learned before. Because of the shortage of the video, I will pass through some main keys of this table. So list is the only sequence that is mutable, which is it can be changed the component inside it. For tuple, string, and range, you cannot change the component inside inside them. And for list and tuple, you can mix between different data types, but for strings, you can only store characters, and for range, you can only store integers. And all for this synthesis, you can use indexing and slicing, which help you to assess each component in the sequence. So I will introduce to you some of the common mistakes that we can make with list and synthesis. There are three three main examples here. The first one is we often confuse assignment with copying. So for example, I have a variable A which store a list 1, 2, and 3. If I assign a second variable B to A, it will be considered as a shadow copy, which when I append B by a new number 4, it will also it will also change the variable A, and because B and A has pointed into the same memory space. To solve it, I will import the copy module inside the Python, and I will also print assign the list, the variable A again. Variable B will using the deep copy method from the copy module. And by doing this, I will create a new list B with the same value of A, but in the different memory space. And when I append B with a new number 4, and it will not affect A anymore. The output here show that A have the original value, while B have the values of A with the new value 4. So the second mistake we can make is we can also mixing up with append and extend in operation with list. So for example, I have a list with three number 3, 4, 5. If I want to add a new list into the original list here, and I use the append operation, it will add the list itself into the original list. So when we print the list, it will contain 2 pairs of square brackets, which is unwanted. So to stores only the component inside the new list into the original list, we will use the extend method instead. I will assign the list again and use extend method with and when I print the list, it will only have 1 pair of square brackets, and this is our desirable output. So the final mistake we can face is we try to modify tuples or strings. As I said in the definition, tuple string is immutable, which we can modify each component in them. So I will show you how to solve this. For example, for string, I have a variable s store the string ABC. If I want to modify the second component inside a string, I can use slicing. There is many ways we can convert into a list, but I will show you the shortest way to solve this. We can use slicing instead. So I will print. I will use slicing the first component, the first letter with range from 0 to the number before 1, which is also 0. It's a first letter, first character in a string, and I will insert the new letter I want to modify, which is F, and the final letter C, using slicing from the index 2, which is the third character inside the string to the last. If I print S again, no, I print it already. If I print it, it will return to our desired output. For tuple, I have a tuple of three number, 1, 3, and 4. If I want to change number 3 to, for example, number 8, I will convert it into a list. And I will also use index. The number 3 is in the index 1. I will assign it to a new value 8 and I print it again. And we have our desired output here.
Okay, so let's come to the first exercise of the second part. So first we will define the list of grades. List grades. And we will take it equal to 85, 90, and 78. So to print out the initial list, we will just have to print and the name of the list of grades. It will return our result. Yes, this is the desired result for the first step. And the next step, we will append a new grade to the list. So we will do a list of grades, append. So something like 80s, and we will print our new grade, list of grades. Here, this is the new list with another element 80s. And for the third step, we will update an existing grade. Since it's a list, you can change elements in it. So I will modify the 85 here into 80. List of grades. This is the first element in the grades into 80. And now we will have our new list of grades. Here, this is our modified list with the first element being 80. Now for the last requirement, I will calculate and display the average grades of all students. I will use the function sum to calculate the sum of all the elements in the list of grades. I will take sum equal to sum of the list of grades. And to get the average, I will take the average equal to sum divided by length of the list of grades. And here we have our average of the score of the students in the list. Print average. So here we have the average of the modified list. For the second exercise, now we have a list of fruits like apple, bananas, cherry, dates, and elderberries. We'll have to write a program to do these 4 requirements. So first I will define the list equal to, I'll copy the list here. So the first thing I will need to display all the fruits in the list using print list. This is to display all the fruits in the list. Here we have our list. And the next thing, I will have to print only the first 3 fruits using the list slicings. And for the slicing, you will do like this. List starts at 0 and ends at the second element. And step, you could take it as 1 or you can just leave it empty. Here, we have our 3 first fruits in the list. The last 2 fruits, we would use negative index to print it out. So I will do the slicing as usual. I will start with -2, which is the second element from the right. And then I will end at the last element is 5. The step I could take is as 1. And now let's print out the result. Here we have our two last fruits here, which is date and elderberry. Now for the first requirement, I will have to print the fruit at the odd positions, and with this, I will have to use the step in the slicing. I will start with the first element, and I will start with the element at the first positions, and I will end at the last element and taking the step as a second. And when I print it out, it will print out the elements in the odd positions, 1 and 3, which is banana and date. Now let's move on the last exercise, exercise 3. This exercise is to create a Python program to demonstrate the concept of immutability in tuples. So you know the tuples element cannot be modified. So we will define tuples here. This tuple should contain 3 colors: red, blue, and green. So what happens if I try to modify one of the tuple elements? I will take tuples 0 equal to 1. Okay, so when I try to run, it will return an error because tuples are immutable and you cannot modify any element in it. So what if I try to modify a list? Here I will have a list with the exact same element: red, blue, and green. I will try to modify the first element into yellow. And now we will have our new list. Yes, we have a new list without any errors because the lists are mutable and you can change any element in it.
We have gone through 2 important topics in Python programming: variables and data types, lists and sequences. For variables and data types, a variable is a name storage location in memory, while a data type defines what kinds of values a variable can store and what operations are permitted on them. The second topic is lists and sequences. A sequence is a general term for an ordered collection of items, where each item can be accessed by its position. Some common sequence types include strings, tuples, and lists. So why are variables and data structures important in real-world challenges? Variables let the program be dynamic, flexible, and readable. There are many advantages associated with storing changing data, memory management, navigation, and so on. Data structure help organize data in efficient ways. Choosing the right one can make a huge difference in performance, scalability, and correctness. So ultimately, I just want to say that don't hesitate to get started, whoever you are. Start your first variables, then group things together into lists, sequences, and start organizing idea in code. In programming, map between ideas and memory lives through variables and data structure. So let's turn curiosity into actions. You will see how amazing it is and how these practices can change our real world lives. In this presentation, we used AI in code demo and comparison table of sequences. That is also the end of our presentation. Thank you for listening.